this convenient formula as a little additional part to the motion problem. And we're going back to initial value problems. So first, we're going to state this formula and have a little bit of a feel about what this formula is about. I think I can go here first. So it's not official exercise, but I want you to go ahead and write this one down and understand the statement a little bit. Write this one down in your personal note. All right, how was it? Did the formula make sense? Do you know where it came from? Right, so if you look at this definite integral, and what is the antiderivative of VW? SW, right? The position function. So if you move this thing to the other side, you see SB minus SA, right? So that's exactly the definite integral. It was slightly rearranged. Okay? But, so, do you see that? How about this W thing? Does that make sense? Yeah. This W, T, or X, it doesn't matter. Once you finish this calculation, once you finish that calculation, it's going to be a number depending only on A and B, right? Area underneath an A and B and then curve V. This variable W, T, it doesn't matter, right? It's a dummy variable, right? Once you calculate that, this whole thing only depends on W. So you can use that instead of T. And you will see why I'm using that instead of T. And we arrange it like this so that we can use this A as initial condition. We know the position at T equals A. Can we calculate the position if we have a velocity function? All right? So that's where this one is used and why it's arranged like that. B is going to be arbitrary. B is not going to be given. B is arbitrary, but A is given. The data says that we observe this thing at T equals A there, that location, position. We have a velocity function. And A we know, B is something that varies. Can we calculate the position? That's the initial value problem, right? We have a velocity and some position at T equals A or T equals 3, for example. Where is it in general? So if you look at the right-hand side, we have all the information in the right-hand side, except B. So I can turn this one into a new equation. B is going to be something that we plug in all the time to figure out where it is other than T equals A. So I can change that to T, that to T. Is that okay? B being arbitrary T. Same thing in here. If you know acceleration and the velocity, the where is initially thrown at some point, then you can calculate the arbitrary velocity at any given time T equals B, right? And we'd like to change that B to T so that you don't get confused with the T up there and the dummy integral variable T down there. So I changed the W. I wanted to make this transition in here. Is that all right? So how about this second formula? I hope that makes sense now. Only difference is that I changed that B to T. Now if you want to know the location of this thing at T seconds, all you have to compute is that SA, which is given, initial data is given, and I know the VW, I know the formula. I integrate the antiderivative and plug in T and A. A is given, T is our variable. All right? So this is the real formula that we'll be using. This formula makes sense now? The W, the dummy variable, you can put Z, whatever, for integral purpose. Make sense? All right. So I hope you can. So how about memorizing? Isn't that easy? Just turning that, moving that negative term in our definite integral calculation to the other side. That's all that is, right? And switch the letter to something else for the integral dummy variable. All right. Let's look at the old problem and solve it in a slightly different way. This was the initial value problem. And the way we solve this problem is that we calculate antiderivative in general, which involves plus c, right? So let's read this problem together. Acceleration due to the gravity is constant function. No matter what your t is always negative 32. And we have initial condition at 3 seconds. The velocity of this one object is measured to be negative 10 feet per second. So what is the equation of the object velocity? What is the vt in general? We know v of 3, right? What is v of 3? Negative 10. Can we calculate vt? We know acceleration, right? So we calculated the antiderivative of acceleration in general with the c in it, right? And then I plug in t equals 3. From there, we'll be able to calculate that constant c using this piece of information. Now we're entering a slightly different formulation of this problem, and I was claiming this is a lot more convenient than playing with that c. We'll see if that's so. Here's a solution. Let me hide that formula. I want you to also remember this formula rather than just reciting that what you wrote down. Vt is related to At, right? So there was this one term, and plus there's integral. Not about this one. In general, A is down there, remember? A is down. What was up there? T. And what's inside here? Right, acceleration. If you integrate acceleration, antiderivative is going to be velocity, right? So I'm going to put A in terms of W here. Is that right? W. But what was the first term in here? Was V of A, right? So Vt minus Va is, of course, Vt minus V is antiderivative of AW, right? Very good. So we know this one, right? Especially what is A here? What's A? A is not 10. A is 3. Time is 3. That's what we know. So if we know V3. You can just stick in 3 there. We know the formula of A. So right-hand side is completely computed, right? So you don't have to solve for C anything. You just compute the right-hand side, and that is the velocity. Right? Yeah. So that's your exercise 1. Use this formulation to compute Vt. So this is formulation in terms of definite integral, right? Not indefinite integrals. All right, was that okay? Negative 32 as a constant function, its antiderivative is negative 32w, right? So if you plug in w equals t and w equals 3, this is what you get. And the constant part works out to be 86, and that was the same number we got last time. Any question? If this t is weird, maybe you should do this whole equation maybe with 5. V of 5 is V of 3, 3 to 5, negative 32 dw or dt. The whole purpose of doing that is you want to get back to the t variable. Once you understand, hope you can come back and get used to the t being in a different place and being able to feel comfortable with this dummy variable. It's good? So let's do one more problem if there's no other question. That was also our exercise problem. And let's see if we can do that one. It has 2 parts. First, you have to calculate f prime from f double prime. Then from f prime, you have to go to f of x as well. So this is our exercise number 2. Since it has 2 parts, let me assign 4 points. But if you get f prime of x, give yourself 2 points. The other one, another 2 points. First, compute f prime of x, f prime of t. It doesn't say it's an acceleration or speed or anything, but you can interpret it as an acceleration and speed and position, right? So, same idea. See if you remember the formula. What was the formula? F prime of t. Let's work this one together. What's f prime of t? the initial value problem formulated in terms of definite integral. The first term was not with the numbers, with a typical 18 there. F prime, right? F prime of A. Does that make sense? Plus integral from where to where? In terms of A and T in general, it's A to T, right? But in this case, it's going to be actual number to T. But what's inside here? F double prime, right? F double prime. Now I'm using W again, dW. This formulation makes sense? F double prime is acceleration. F prime is velocity. F is the position, right? If you want to look at it that way, it's easier. Any question about this formulation? Make sense? Now what's A here? Is that 3 or 5? A. Are you sure you say A is 3? A is 0, right? It's not 3 or 5. A is 0. The time t equals 0. Alright? So that's your first part of the exercise. Right? How was it? F prime of t? F double prime of t cosine is antiderivative of sine in terms of w, so you stick in two values there, and you get 3 plus sine t. Any question? So if you got this one right, there's 2 points, and the next part is that, so now you know f prime of t, so go backward one more time to compute f of t, right? So let's think about the formulation. What is the formulation here? What is f of t for this initial value in terms of definite integral? First term. Anybody like to go for first term? F of 3 or f of 5? F of 0 is correct, right? The initial time, and plus going from 0 to t of f prime of t is, that's a derivative in there. But I have to use w. How about that? Does that make sense? Antiderivative of f prime is this one in here. Alright, so we have all the information. We know the full formula of f prime. We know the value of f of 0 that's given in the problem. So we can compute this one. Yes, question? Yes. When you formulate this problem right here, that's where the first time the 0 to t is appearing here, right? So you have to understand why there's a 0 to t. Correct? The reason I chose the 0 down there is because that piece of information is given in here. Right? So I can change this problem like f prime of 0 equals 3. Then I crossed that out. I gave you f of 1 equals 5. Right? So you use f prime of 0, so you enter 0 to t here, right? So you got that formula, same formula. When you enter f of t, you don't want to consider f of t of f of 0 plus 0 to t, because you don't know anything about f of 0 at that stage. If it is given like this, you only know f of 1 equals 5, right? So you will consider f of t equals f of 1 plus integral from 1 to t and that, so that you know information about f of 1, so it can be a number. And when you calculate this one, antiderivative, you plug it in. No matter what that number is, you can calculate this part always. But this part here requires information. So you use that, whatever is given. And this number, 0, and that number must be the same, so that this whole equation makes sense. Right? Any question? Does that make sense? Mm-hmm. So the reason that t is there is the question is to figuring out the formula of ft in general, not f of 5. You're not asked to compute f of 5 or f of 6 or anything. So you have to keep that value in general like the t. Then it gives you the trick of actually being able to solve all that information. Right? Just like a b, rather than replacing the b with something, just keep b in there. Yeah. Then you can use tt here. That's, again, psychologically more, you're more comfortable with that part. So you could have done this problem with f of b equals, without knowing what b is. In general, if I have b, how do I calculate position? And you can use that initial information that's given, then going from 0 to b, that an arbitrary position, then you stick in f prime of t dt, right? Going back to usual t. Now if you calculate this one, t disappears, right? Antiderivative has t, but as you plug in 0 and b in there, t disappears. Only left with b in there. So the right hand side formula is formula of b, right? So in general, if you want to know position at b second, then the formula that does not involve t in it, eventually, after you calculate all that, t disappears because of this definite integral. That's the difference between definite integral and indefinite integral. Indefinite integral, without these numbers, this whole second term will have t in it, right? N plus c in it. But if you do definite integral, it only depends on this limit and that limit. The t disappears. Yes.